Hello, welcome to Ekidel. We are trained future civil and structural engineer. My name is Justice Mwaka and I am your instructor. Today, I will be showing you the part 17 of this structural design. And on this design, this is a 16-story building and we are on the part 17 of this high-rise building design. And the software that we are using the software ProtaStructure, and we are designing to what? Eurocode. So Eurocode is our design code for this 16-story building. So, but if you are new on Ekidel, I would advise you can watch the part 1 up to part 16 of this video, because currently we are on the part 17 of this video and we are on the interactive stage design, where the structural engineer will have to now interact with the software. So right now, currently, I have already done on the part 16. We did the first interactive design, where we have to interact with the software and check all our columns and all that. And also we checked few of the beams, which I now instructed you guys to go and check for the other beams, because I have done more videos on how to check your beams using the software ProtaStructure. So currently right now on this pool area here, which is this pool area here, I left these columns on this pool area so that I can work with you guys and so that you can see how to now check your columns. As you can see right now, these columns around the pool here is not sufficient to carry the load of this swimming pool here. So currently, that's why all the columns around the pool area are failing. So I will now be working with you through on how to now check the columns and see why it is failing. If the size of the column is not sufficient or not, then we can now check on that. So right now, to now check on that, I'll just click on the column here which is failing on this floor, which is the 16th floor where the pool is, and then right click on the column. I'll be working directly on this 3D view here. So I'll now click on that and then come here and then click on what? Section design here. Now on this place now, I'll then go over again, and once it shows the dialog box for that, I'll then go over and then click on the try to check why it is failing. Now if you are new on Ekidel, you can check on the link down below and download the CAD file and then follow us up on this design project. So right now we will now move on to the next here to now check why it is failing. And by doing that, the first thing I'll do right now is to come here and click on the place that says interactive design. So I'll click on this right now and check why there is a failure on that. Okay, so you can see the warning here that says that steel bars cannot be selected because the section size of the column is insufficient. So right now we have known the issue why the column is failing. Okay, so right now I'll just say okay and then come here and increase the size of my column. So I would like to use 400 by 400 column size that will be able to carry the pool, and then I'll come here and click on updates, and I'll come here and click on reset bars. Okay, and I'll come here and then click on interactive design here, and now you can now see that the bars that is now required to carry the pool is 12 diameter 25, which is for the column. So I'll come here right now and then say okay, and then come here and then say final okay here, and with that now you can now see that this column right now will now be okay. So right now you can now see that it is okay. If I now click outside here right now, you will see that the columns is now okay. As you can see right now, this column now is now okay because we have increased the column section. So I will go then again and repeat the same thing for the other one here. Let me just click here again. There's filling. Right click now and then click on something here. Now if you don't know what they call let me say a story building or building that has a swimming pool at the top, you can really check out this right now here. So right now on this, I'll just come again right now and then increase the pool again here by 400 by 400 again, update, and then come here in design here and I'll wait for it to design. Okay, that's fine. So with this now then say okay and then final okay here, and the column now will now be okay because we have just increased the section. That was what was causing to fail. So with this, if I click outside here right now, you can see that this column now is now perfectly okay. So again now I'll move again to the next one here. Let me check this other one here. Check this right now and check this here. And now click on here. Now if you're new on Ekidel, I would advise you subscribe to our channel Ekidel, because here on Ekidel is the #1 platform. We are civil engineers and also structural engineers have been trained around the world. Okay, so I'll come here right now and click on okay, and then interactive design, and then click on okay here and then okay here. That's fine. Okay, so again I want to move again right now to now check this again. Click on this here, right click here and then this, and then come again right now and then come again here, check why it's failing basically, It should be from the section of the column. Okay, no, here this is that steel bars what is exceeded. Okay, that's steel ratio. So right now I'll just quickly come here and do what? Reset bars, design again, and see why it's failing again. Okay, descent issue. So I'll come here right now and then increase this to 650, update, reset steel bars, and then come here again and let's see descent issue again. Okay, and I'll come here, reduce this back to 600 and increase the width of the column to 350, and then okay, update here and then say design here. The same thing again, the steel ratio limit is what exceeded. Okay, that means that the section of the steel is too much. Okay, so I'll come here right now and then say what okay here, and I'll come here, reduce this to what 400 by 300. Let me see. Okay, update and then come here, design. Okay, now they're saying that the section is what insufficient, so I'll come here again and say okay here, and I'll come here and make this to be what 400, and I'll come here and then okay, and then design here. The same thing again. Okay, so I'll come again right now and then change this to what 600 by 400, and then say what update here, and then come here and then say what design, and then so you can see that this is now what sufficient, because we have now seen what our bar size, which says 16 number of what Y25. So right now this is now okay. Now come here and then say what okay here, and then say final okay here. Okay, that's fine. So we will now move on again to the next column again that is failing, because this one here is already okay. So I will now go again right now and locate the next column which is failing at this corner here, and click on this just now, the column itself. Right click here and then do what? Click on what? Design here, and then come again right now and then come here. Let me just do 400 by 400, update, design. Sorry, reset bar first before you design, and then that's fine. Okay, and then okay here. Okay, so right now you can now see that we have now checked for all the columns that are failing, as you can see that. So basically right now you can now see that, let me just check this out. Okay, that's fine. So you can now see that we have checked for all the members of this 16 story building here. As you can see, we have checked for all the members and none of them is failing. Okay, so once you're done with your structural design using this software or using any design software at all, you must have to check the software. That is the duty of a structural engineer. You must not depend on what the software gave you, because these things are programmed software. They are terms to almost all the softwares are programmed to perform what they call over design, because what they are interested is to ensure the safety of the structure. So most softwares perform over design. So that is why they always give allowance for what they call interactive design, where you as a structural engineer will now have to come and interact with the software and all that to now use your own experience to now arrange your reinforcements, choose your section wisely and all that. So I would advise that for upcoming engineers, learn how to interact with your softwares. Although for you to interact with your software very, very well, you must have known a manual design knowledge and all that, and the principles. If you don't know the principles that are involved in manual design, you might not be able to interact with the software very well. That is why, to just help that on that, and since our mission here on Ekidel is to build up and also train the future engineers, we have a program called Ekidel Mentorship Program or Mentorship Class or training, specifically on design of structures and also detailing. So if you are interested to improve yourself on what design of structure, you can enroll on our Ekidel Mentorship Class or training on design. And also if you want to also improve yourself on detailing, you can enroll yourself on what they call Ekidel Mentorship training in the area of detailing. So these two, they are different. They are not the same, and they are not expensive. They ranges from $380 to $480, and you can make part payments up to 3 times. So you have the chance to make 3 times payment installment and all that before the end of the training. If you want to enroll for that, you can check on the link down below and enroll for that. It is not like a video that is being recorded. It is like a live stream training where we use either Google Meet, Microsoft Teams or Zoom to train you on that. So It is like a live stream training where you have to see us real time and all that. So if you want to get that, you can check the link down below and change your life on that. Okay, so thank you so much and God bless. Now we are about entering into the part 18. Now the part 18, as we promised, that this 16-story building will be the first high-rise building that we are going to design and complete. That is why we attach the CAD file down below. Although the CAD file is not free, so you have to get it and purchase it and then follow up the design procedure from what we have done from the part 1 up to the part 17. So currently now we are done with the superstructure design. We are now entering into the substructure design, which we are going to use a pipe foundation for that. So we have not really done any design video on pipe foundation. So on this video, this video will be the first project or building that we are going to use to design for a pipe foundation. So I would advise you follow up the substructure very, very well, because from next week we will start uploading the video for the substructure, which is the pipe foundation. And knowing that pipe foundation has 3 stages. The first stage is to design for the pipe cap. The second stage is to design for the pipe itself, and the third stage is to design for the grade beam, and then you can now enter into detailing. So we will be working with it stage by stage. Now on the part 18 will be on the pipe cap design, although we will have to explain much about the pipe caps that you will be able to get the full knowledge about pipe cap design. Then we will also try to relate it also to manual knowledge, and then tell you the principle that you are meant to check out for when you are designing for your pipe foundation, basically for pipe cap first. And then from there, we will now walk you through into how to apply the knowledge which you know in this software. Because this software, most software basically, if you don't know how to impute the values very well, then you get it wrong. So we'll guide you on how to design pipe cap following with this software, ProtaStructure. And then when it comes to the pipe design is being done using detail. Pipe cap is being done using ProtaStructure, while pipe design is being done using detail. So we will also walk you through on how we are going to transfer the load onto the pipe. You understand? And then we will now come and then design for the pipe connecting beams and all that. Although before we design for the pipe cap, I will give you a pipe soil report, because we cannot design pipe without using a soil report for that. So basically the subgrade or the structure design will take longer time, because except you don't want me to explain much. Now for those of you following this video, I would like you to comment down below if you have any issues along your own design, because I know that over 200 persons are following this video, are following this design currently. We are currently up to 4,000 subscribers, and currently 200 persons are following this video. Now you can also join the WhatsApp group down below, so that you can be able to interact with other engineers globally around the world and all that, and share also what you know. And also if you have questions along your design, you can also drop the question and they can be able to assist you. Okay, so thank you so much and God bless you. See you again on the part 18 of this video, which is now the substructure design, okay, which is the foundation design. So bye for now, and then see you again next time tomorrow.